So this is the second of two videos from the same section, section 4.1 of the textbook. And this is mainly just looking at more complex expressions with polynomials. Honestly, this is not as important as the previous one. The previous video covers the basics, and really that is, builds upon what the review lesson was before. But if you feel like you can have, or want to have a really strong, proficient understanding of this work with polynomials, then we should be able to approach questions like this in this course. We won't see a lot of them, and if we try to jump to this too quickly, it can just become overwhelming. So I don't recommend really putting much time into this until we first, maybe not mastered, but become quite proficient, quite confident with the work in the last lesson. That said, once we get to there, let's, this is, honestly, I think this is a boring question, but it's full of important skills that we need to become confident with, especially if we want to take pre-calculus courses. But it's a lot of little steps. And so first, what I have here is x plus 1 times 5x plus 3. I have two factors being multiplied to each other. Here I have three factors being multiplied to each other. 3 times 2x plus 4 times 6x minus 2. And eventually I'm going to add all these together. This is kind of similar to an elementary school question where we have, let's say, 2 times 5 plus 3 times 6 times 7. Okay? Two factors plus three factors being multiplied to each other. Now, granted, we have polynomials instead of constant numbers, but it is similar in that way. So what I want to do first is just focus on these parts separately. And actually, even be more detailed, I want to focus for the second part just on the 2x plus 4 times 6x minus 2 first. Leave the 3 for a bit. That said, let's multiply this out. So here, again, I'm going to do this fairly quickly because all the sort of steps I have individually I've kind of talked about. So if you look at what's highlighted in yellow, if you multiply this out, you should get 5x squared plus 3x plus 5x plus 3. There's a couple like terms there, 3x plus 5x, so I'll put those together right now. And I get 5x squared plus 8x plus 3. OK, so all of that is equivalent to what we have in yellow up there. What do you have highlighted in green? I'll do the same sort of idea rather quickly. So we see highlighted in green is the same as 12x squared minus 4x plus 24x minus 8. And again, there's some like terms. In this case, the minus 4x to plus 24x. Put those together. You get 12x squared plus 20x minus 8. OK, but this time, all of this is still being multiplied by 3. All right, I've done a lot of steps, a whole bunch of little steps. That said, there's not a heck of a lot left. I have this, everything you see in green is highlighted, that's highlighted in green is being multiplied by 3. So let's multiply out the 3 now. And so this becomes 36x squared plus 60x minus 24. And then I still have these terms that were highlighted in yellow up here. And now I've done all my multiplication. There was a lot there, a lot of little steps. Now I want to combine like terms. And I have like terms for x squared. Put those together. You get 41x squared. I have like terms for my x's. I've already combined some previous like terms earlier, so I get 68x. And I have like terms for my constants. 3 take away 24 is negative 21. Now, fair enough, I did that quite quickly. Like I said, I'm assuming that if you're paying attention to this video right now, you have already put some time into the previous, not only lesson, but actually work. All these lessons require practice. That said, while there are a lot of little steps, once we become proficient with the steps, it doesn't have to take that long. And I will never ask you to do lots of these. With that said, though, the next question is the exact same thing. The only difference is I have a minus right there. So I want to think what difference that makes. Exact same thing. So it's going to be almost all the same work. But it's minus 3 right there. That said, all of this I've done already, so I'm going to skip the part highlighted in yellow. I've already multiplied all that. I'm going to skip right to where I've collected like terms. So 5x squared plus 8x plus 3. Again, this is the exact same question we just did, just I'm subtracting 3 times everything instead of multiplying. So similarly right here, there's no point me redoing all that from scratch. We've worked it out already. That's 12x squared plus 20x minus 8. Really, I just want to think about what difference it makes having a subtraction with the 3 instead of addition. Well, the difference is now comes into play right here. When I multiply out this 3, when I distribute the 3, I want to think of it as a negative 3. And so all the signs are going to change compared to what I had before for these 3 terms. I have negative 36x squared. I have negative 60x. And I have positive 24. That's it. That doesn't affect what is highlighted in yellow until I collect these like terms together. And now, collecting like terms, 5x and negative 36x squared is negative 31x squared. 8x, take away 60x is negative 52x. And lastly, 3 plus 24 is 27. And so again, the more subtraction you have, the more you have to be careful about signs changing, right? Anytime you multiply negative by negative, we know we get a positive and so on. But again, lots of little steps, probably a total of 10, 15, 16 steps on both of these questions to get to the final simplified answer. Each of those 15, 16 steps is very, very, very quick. But if we don't have the previous mastery of those little steps, then yeah, don't even bother with this. I mean, we have to first focus on understanding why, for example, everything you see highlighted in yellow is equivalent. So that's it. All I've left is a final problem. Again, coming back to a visual, this time a 3-dimensional visual. I start with a cube that I say has a side length of x. So let me just make sure we're clear what that means. That means if I look at this cube, and all the sides have to be the same, otherwise it wouldn't be a cube, and they're all x. And they're all the same. So x, x, x. Length, width, height. They're all x. What number is x? It's not so much that it can be anything you want. I mean, it can't be negative. But essentially, the idea is I just don't care. X is just a number, right? I don't really care. I mean, you can, and that's so it's not something I'm trying to solve. It's a number. So it's a positive number. Otherwise, you know, a negative number doesn't make sense. But other than that, it's just some number. And so I want first an expression for the volume of a cube. Well, remember, a cube has a very simple equation for volume. It's length times width times height. But with a cube, those are all the same. So in this case, it's x times x times x, which is x cubed. And again, that's why we call a power of 3 cubed, because it makes a cube. I mean, that's exactly why. It's not a coincidence. That's literally the reason why. OK, and that's why, that's it. X cubed is the volume of this cube you see here. Now I'm saying, what if each dimension is increased by 1? So length, width, and height are all increased by 1 unit. So expand and simplify that. So that means each of these dimensions here are no longer x. They're x plus 1, plus 1, plus 1. That's what it means. They're all 1 unit more. OK? And so the volume now would no longer be x cubed. The volume would be x plus 1 cubed. And hopefully, again, we realize if we start doing stuff like this, we're making the exact same mistake I brought up in the first minute of the last lesson, actually, in which, you know, we can't distribute when we have multiple terms inside here. If it was x times 1, you could do that, but it's x plus 1. These aren't factors. But it's a common mistake. And so I'd encourage you to write down, this is not the same as x cubed plus 1 cubed. Very common mistake, though. So what is it the same as? Well, let's think what x plus 1 cubed means. It means x plus 1 times x plus 1 times x plus 1. And so now, how do we do this? Well, we've learned already from the last lesson and hopefully practice a fair amount. Just 2 of these. Oh, here's an announcement.
Attention teachers, if you have any more Terry Fox money, please bring it to the office as soon as possible. If you have any Terry Fox money left over, please bring it to the office as soon as possible. Thank you.
I don't have any Terry Fox money left over. All right, so let's just ignore that last x plus 1 and just work out x plus 1 times x plus 1, which again are going to have 1, 2, 3, 4 steps. When you multiply those 4 steps out, you get x squared plus x plus another x plus 1. and combine like terms, you get x squared plus 2x plus 1. Again, I'm doing this pretty quickly because, again, I'm assuming if you're looking at this and paying the appropriate attention to it, you have, practiced a fair amount before then. Again, if you're just watching it and you haven't practiced it, this honestly is a waste of time. That's it, okay? But all this still has one more factor of x plus 1. So we can't forget about it. And now I need to multiply everything here by everything here. And we saw a similar example in the last video, in which I'm going to have a total of 6 multiplication steps. First, I'm going to have x squared times x, which is x cubed. And then I'm going to have x squared times 1, which is x squared. OK, that's 2 of my 6. What's next? And again, it doesn't matter the order. I just don't want to lose track. Next, I'm going to do 2x times x, which is 2x squared. Hold on, I made a mistake. Did I make a mistake here? Oh, no, I think I'm good. Sorry, I'm just double checking. Never a bad idea. OK, yeah, just making sure. Then I have 2x times 1, which is 2x, or positive 2x. And then all that's left are these 2 steps right here. I'll draw it like this. 1 times x, which is 1x. And 1 times 1. Ended off with something really complex, 1. And now it's a matter of collecting like terms. There is only one x cubed term. X squared terms are these 2, so I have plus 3x squared. X terms, I have these 2, so that's plus 3x. And then plus 1. And so, again, the main idea of this is first understanding, like I said, why we call something x cubed to the power of 3, because it makes a cube. And then understanding, in this case, if I add 1 to each of those dimensions, especially that something like this is going to be incorrect. Yeah, I have to do a few steps. Are there faster ways of doing it? Well, yeah, but not, first we got to learn way more for that. And honestly, I'm not going to ask you to do this too much. So the faster ways of doing this require so much other stuff to talk about that it's actually not, in the end, faster, if that makes sense. OK, last one. Same idea. This time, I'm changing only various dimensions by different amounts. I'm saying the width of the original cube is increased by 2. The length is decreased by 1, and the height is left unchanged. So what does that mean? Well, remember, volume is length times width times height, in any order. So I said the length is decreased by 1. And so it was x before, so now it's x take away 1. The width is increased by 2, so it's the original x plus 2. And the height is left unchanged, so the height is just x. And now I want to work this out, which is actually, I think, in many ways easier than what we did before. And that's because when I multiply this out, all I have left is to multiply everything that's left by x. But again, I have 3 factors. X plus 1 is a factor, x plus 2 is a factor, x is a factor. And I can multiply these factors in any order. I'm going to start with what I've underlined in red. If you multiply everything you see in red, you get x squared minus x plus 2x minus 2. Combine like terms. Like I said, I know I'm doing this quickly. You can pause this all you want. OK, that's the part that's underlined in red. But all of that is still being multiplied by x. Actually, I don't even need brackets around that x. Right, all this up here as well was being multiplied by x. And now I'm going to multiply this all by x, which is actually quite pleasant. Just literally x times x squared is x cubed. X times x is x squared. And x times negative 2 is negative 2x. Like I said, I think this is actually less work than the last question. But you may disagree with me. All right, so in terms of the algebraic work for this part of the chapter, everything we did today is not nearly as important as the last lesson. That builds the foundation of what we need to use a lot. This is more going into the more sort of intricate examples. There's not a lot of homework from this section, but the questions are a bit more involved. And again, there's no point even looking at them until you have mastered or almost mastered everything before that. OK? So then, I just want us to be clear not to try to jump to the most detailed sort of algebraic work too early. Okay, this is not as important as the previous part. The previous part is more important. And I'm going to